Okay, so let's look at forming some quadratic equations from the roots. So this is something that you would have done a little bit at junior cert as well, and you would have done it a particular way at junior cert. We're just going to introduce another little quick rule that can help us with these questions, but in the vast majority of cases, you can actually do it in kind of the same way that you have done it already. Um, but this rule can just help us along. It can just save us a little bit of trouble sometimes. So if we're looking for the roots of a quadratic equation, or if we're given the roots, we can use it to find the quadratic. So obviously if we're given the two roots, we know that that means that x equals this or x equals this. We can combine them into factors and we can multiply it out. And when we multiply it out, we end up with a situation like this, where we have x minus or1 plus r2 plus or1 times r2. And we can actually generalize that into this kind of formula that we have here, where for any quadratic, the quadratic can be written as x squared minus the sum of the roots x plus the product of the roots. Now the one thing I'm going to immediately say to watch out for is the fact that it's minus the sum of the roots. And if you're ever unsure, come back to this idea. You can use this to derive that. Okay, you can derive that idea using kind of what you know from junior cert already. We can use that to derive this idea, but just making sure that you kind of are applying it in that sense, okay, that you're following through in that idea, and that you kind of know off this quick rule. Okay, we're going to see in these questions here how that can help us along. Now I have put in a note or two for us here. The first one says there are infinitely many quadratic equations that would have those roots, and that's an important one. So there are any number of quadratic equations that would have those same roots. So this method allows us to form one such equation. If we multiplied that equation by 2, that would be another equation. If we multiply it by 3, okay, and particularly this is going to come in when we talk about functions. So in equations, those factors don't matter as much, but in functions, those are really going to determine the function we're talking about, and they're going to have a real impact on what we're looking at. So important just to note that with an equation, this is giving us one such equation, and this is why they will generally say form a equation. They won't really give you a particular one to work with most of the time. The other thing is that this rule works for equations with leading coefficient 1. So this rule only works if it's 1x squared. Okay, we can kind of see it in the rule there. It's only written for 1x squared. It's not written for ax squared or something like that. So in some questions, we may have to factor out this coefficient before we begin. So let's just go quick, form a quadratic equation with these two roots. We're going to use our little quick rule. So x squared minus the sum x plus the product equals 0. Okay, we're making an equation, it has to be equal to 0. So x squared minus the sum, so adding them together, a half plus 5x plus the product, multiplying them together then for the product. So x squared minus, let's see, 5 over 2 would be the same as 5, would be the same as 10 over 2, so minus 9 over 2x minus 5 over 2 equals 0, and I can multiply across by 2 there to give me a nice standard equation, okay? Just noting as well that generally with a quadratic we don't write it with fractions there, so we can give it a leading coefficient. We can also use this rule to find unknown values if we're given a quadratic equation. So say given this example here, we're asked to find the value of c if one root is 4 times the other. So let's let the first root x1 be or, and we'll let the second root be 4 times bigger, so 4 or. Okay, the second root can be 4 or. Then I'm going to use my little quick formula again, because it saves me a little bit of trouble. I'm just going to put that together. So minus the sum, so I add them together here, and here I multiply them. Okay, and bringing that all together, I get 5 or here plus 4 or squared equal to 0. If I compare that with the equation in the question, I have 5 or x there, and I can compare that with the plus 10. Okay, we should be thinking back to our inequality or our identities here from the first algebra chapter. So we're comparing those examples here. So minus 5 or is equal to 10, which says to me that the first root must be minus 2. So my first root must be minus 2. And then I know that this last part, 4 or squared, is equal to c. I now know what or is. So 4 times 4, so I'm getting that c is going to be c is going to be what? It's going to be 4 times bigger. Okay, so the other root is 4 times bigger, but I can get my value of c here being 16, and I can get my value for R2 if I want. It's just minus 8. Okay, so I can get my value for c, and I can get my value for R2 as well. So let's just look at a practice question or two. Form a quadratic equation with each of the following roots. We're just going to be using, again, our quick rule here to help us out. Making sure equal to 0, I suppose, at the end. So x squared minus the sum, which is 17, plus the product, which is just 72. And let's just, I suppose, write that out again. Equals 0. Nice and straightforward. Okay, nothing really to catch you out particularly there. Here next, in the next one, we have some square roots going on, so just to watch out for. But same idea applies. Minus 2x plus the product, multiplying the two of them, making sure it's equal to 0. So we get x squared, and we can separate it out if we want to, or we can leave it as is. Things trying to call it a day. Okay, and the last part, minus 2 root 6, and again, just equal to 0. And just with the little last one, just to be careful, I suppose, of your different fractions there. It's minus 7, 8, and your signs as well, I suppose, particularly for the product part here. And equal to 0. So if I add those fractions together, I get minus 5 over 8x, and multiplying them together gives me minus 21 over 16, and I can multiply across by 16 there. 16x squared minus 10x minus 21 equals to 0. Okay, we're going to look at an exam question or two. I'm actually going to jump to the second exam question first, because it's maybe a little bit easier than the other one. The other one's quite an older exam question, I suppose. So let's have a look here. X squared plus 5x plus p. We're given these values. Find the value of p for which f of x has roots which differ by 3. Differ by 3 means one is 3 bigger. So we can kind of label that however we want. If we let the first root be a, we could let the other root maybe be 3 smaller. Okay, so they differ by 3. You could add on 3 either. It should give you the same result regardless. Let's use our little rule here. So in here we put the sum of the roots, and at the end we put the product of the roots. Okay, and again, we're just going to work this out for ourselves here. A squared minus 3a equals 0. We're going to do some comparing here. So the plus 5 is going to be compared with all of this part, and we're going to have to take the minus with us, because we have to consider that the 2a minus 3 here has to be negative, because the answer is going to be 5. So whatever a is going to make that middle part a negative result. Then we're going to get our overall answer by comparing the pink part here. So let's just take this over to the side. I'm making sure to keep that negative on the outside, because what actually happens is I can distribute that fully across the bracket there. And that, of course, gives me a different answer than if I was just to take it as negative in the first place. Okay, so we've got a nice result there. We've got a result for a being minus 1, so my first root is minus 1. I know then that a squared minus 3a is equal to p, and I can sub in that value for a everywhere that we have a. So 1 plus 3 equals p, and I get that p is 4, which as expected is a nice integer. It is between the two results that we have there, the two values that we required. Let's look at this first exam question then. So 2009, so a bit more challenging, but the same idea applies. They tell us that one root is n times the other root, and we're asked to express or in terms of p, q, and n. So what I'm going to do here first of all is I'm going to factor out p. Okay, I'm going to factor out p. Because it's all equal to 0, I can actually just simply divide across by p, remembering that because p is a coefficient, it is just a number. Okay, it is just a number. We don't know what it is, but it is just a number. Now that I've done that, I can kind of use my general idea here. So again, my usual little rule, sum x plus the product equals 0. Okay, so bringing it all together as best we can. If we line these things up, okay, if we line these two things up, the sum here minus the sum is equal to q over p. So let's just take that idea. So minus the sum of my roots is equal to q over p. So that says to me, if I divide by that minus 1 or multiply by minus 1, that the sum of my roots actually gives me minus q over p. Then similarly, if I look at the product of my roots is going to give me r over p. So let's just define our roots here. So let's let one of the roots be a, and if the other root has to be n times bigger, let's make it just na. Okay, n times n multiplied by a. Let's get the sum. Okay, so the sum obviously is just going to be a plus na, and we know that the sum is equal to minus q over p. Okay, remember we've done this calculation down in the bottom right corner or left corner here as to why it's negative. Now, we don't fully know what's going to be happening with that there, so let's just leave it for a second. The product then, of course, is just na squared, and that's going to be equal to r over p. Now, what I can see here is they want me to express or in terms of p, q, and a. The one letter they have left out is p, q, and n, sorry. The one letter they've left out is a. So whatever we end up with shouldn't have a in it. It does need to have or, and it does need to have p, and it does need to have n. So looking at the question here, I can kind of see that if I can manipulate this side, the product side, maybe using the sum, I can maybe eliminate a. And kind of similar to maybe how we look at our simultaneous equations and things like that, I'm going to factor out a here and try and rewrite this side so that it's a equals something. And we get that a equals minus q over p times 1 plus n. Now what I can do with that whole answer, here, is I'm going to sub that into this right-hand side question instead of a. So I'm going to have n times minus q over p times 1 plus n equals r over p. Okay? So now we've eliminated a. Let's just highlight that so we can kind of keep track of where we're coming from. So we've eliminated a there completely, which is kind of the ideal scenario. The only other thing we want to do is we wanted to express p, and making sure that's squared. We wanted to express p or in terms of the other letters. So let's just first of all square this side. So I get q squared over p squared by 1 plus n squared equal to r p. And if I take this continuing out to this side here, if I multiply both sides by p there, I get an overall total of n q squared over p plus times 1 plus n all squared. Okay, definitely a challenging one there, which I suppose is the point. That's why I put it in. A challenging question. Okay, we're not even done yet. We've only done the first part. It's kind of bringing in elements of your identities from the first algebra chapter. It's really pushing you to really grasp what you're looking at. What does this little rule mean? Okay, how can I apply it to my question? So it is pushing you that little bit further. Now they've told us, they're giving us kind of another quadratic here. One of the roots of this quadratic is 5 times the other root. If q and r are positive integers, determine the set of possible values of q. So let's have a look at the question. Here I can see if we compare it to the top part here, in this bottom question, p just has a value of 1. And n being the number of times, is 5. It's 5 times bigger than the other root. We already know from this last element here, okay, we already know from this kind of last section that r is equal to nq squared over p times 1 plus n all squared. Okay, so we can use that to help us find values for r, for example. Okay, because we're told both q and r are positive integers. So let's just use our answer from the last part. So nq squared over p times 1 plus n squared. We're going to fill in those numbers that we know. We know n is 5. We don't know q. We know p is 1. And again, n is 5. 5q squared over 6 squared, which is 5q squared over 36. Okay, 5q squared over 36, or we could leave it as 6 either. Okay, now the key thing here that they've told us is that r is an integer. Okay, r and q are integers. R and q are both going to be integers. And what that means for us is that 5q squared is divisible by 36. Why is that? Well, if this result, okay, so that should be or here, if this result down here is going to be an integer, that's going to mean that 36 divides in evenly to the top result with no remainder. Otherwise, we don't get an integer. Otherwise, we get a fraction or a decimal of some sort. But we've been told it's a positive integer, so we know that it has to divide in evenly. Okay, now 36 is not going to divide into 5. Okay, 36 does not divide into 5, so that actually means that q squared is divisible by 36. Okay, whatever we multiply by, if we multiply q squared by 5, factors of q squared are still going to divide in. If q squared is going to be divisible by 36, that's going to mean that q is divisible by 6. And we end up then that q is going to be the set of multiples of 6. Okay, positive multiples because or has to be positive. Okay, positive multiples because or is positive, but also I suppose because q is squared anyway. It's not gonna. But we know q as well is positive. So positive multiples of 6. Okay, so q squared has to be divisible by 36, so that means that q, of course, is divisible by 6. So whatever I square has to be divisible by 36, so whatever it is itself should be divisible by 6. So q is going to be positive multiples of 6, okay? That last part there, quite challenging, okay? Obviously, it's from 2009. It's from, I suppose, an older version of the course, but really just in a section that is fairly okay. It's just to push you a little bit further, have you kind of thinking about what the questions mean. Really prioritize these sorts of questions here, the 2020 question, and say these questions here, and this one here as well. So prioritize those sorts of questions when you're working through it, and you'll be grand. You'll be grand with that sort of section. But making sure that you know your little rule there and that you're able to derive it if needs be as well.